Dear student, my second video on types of matrix. After the introduction of matrices, I am going to upload this video where I will discuss type of matrices. So the types of matrices totally depend on the order. And so first is I am going to discuss here uh, rectangular matrix. Rectangular matrix, that means matrix in which when the number of rows are not equal to the number of column. And there are two types of matrices which are called rectangular matrices. First is row matrix, it is also known as horizontal matrix, and second one is column matrix, it is also known as vertical matrix. So in row matrix, you can see the definition of row matrix. I have written a matrix which has only one row and n columns where the value of n is equal to 1 or more than 1. I have written an example of matrix A, 1, 2, 3. The elements of matrix A are 1, 2, 3, and the order of matrix A is 1 by 3. That means the number of row is only 1 and the number of columns are 3. That means you can say a matrix which has only one row but many number of columns is called row matrix. And now second is column matrix. So column matrix is just opposite a matrix which has only one column and m rows. That means the number of rows are more than or equal to 1, but the number of columns should be 1. I have written example of matrix A. 1, 3, 4 are the element of matrix A, and the order of matrix A is now 3 by 1. That means the number of rows are 3 but the number of column is only 1. One more important thing, if a matrix of order 1 by 1 is called row as well as column matrix. If suppose a matrix is given of 1 by 1 order, we will say it row matrix also, and we can say it column matrix also. So this is the best example of a matrix which is a row as well as column matrix. And after rectangular matrix, now next square matrix. So square matrix, it is very easy. When the number of rows are equal to number of column, then matrix is said to be a square matrix. I have given two example. In matrix A, it is the order of matrix A is 2 by 2 and order of matrix B is 3 by 3. You can see it is very clear. When the number of rows are equal to number of column, then matrix is known as square matrix. And now third number is zero matrix. Zero matrix, it may be square matrix, it may be rectangular matrix. Okay, first of all, very important thing. And zero matrix is also denoted by null matrix. And this matrices, these matrices are rectangular as well as square matrix I have written, and all the elements of null matrix are zero, and it is denoted by O. O is a English alphabet letter. We denote null matrix by a special letter O. You can see an example of null matrix. First one is rectangular matrix, because the order of first matrix O 0 0 0 only one row but three columns, the order of matrix is 1 by 3. And second null matrix is the order of 2 by 2. There are four elements you can see here. And now diagonal element. Before knowing some more definition of matrices, diagonal element, we should know about diagonal element. We find diagonal element only in a square matrix. That means we will get diagonal element only in a square matrix, not in rectangular matrix. So if a matrix is given and the elements are diagonal, how can we recognize the given elements are diagonal element? Aij is called diagonal elements if the value of I is equal to j. And suppose a11 is written, a22 is written, a33 is written. A11 because the value of I and j both are 1. A22 the value of I and j both are same, which is 2. And a33 where the value of I and j also same. If suppose a13 is written, 1 is row, 1 status row and 3 status column. That means a13, the position of element of a13 is element which lie in first row and third column. Now you can see 1 is not equal to 3. So these type of elements where the value of I is not equal to j are called non-diagonal elements. So it is very clear, aij is called diagonal element if I is equal to j, and the line where these elements lies is called principal diagonal. That's very important thing. The line where aij, where the value of I and j both are equal, is called a principal diagonal. Clear? Now next, diagonal matrix. I think it is very clear to you what is diagonal elements. Now you can understand diagonal matrix. A square matrix, that means if we are discussing about diagonal matrix, and first of all the very important condition is that matrix should be square. If a matrix is square, then it should be diagonal. It should be diagonal, but under some condition. The condition is that aij is not equal to 0 when the value of I is equal to j. If the value of I is equal to j, then aij is not equal to 0. That means a11, a22, a33 never be equal to 0. And aij is equal to 0 when the value of I is not equal to j. That means all non-diagonal elements are 0. So I have written here three examples. You can see matrix A, matrix B, and matrix C. The all diagonal elements of matrix A are 1, 2, 3. Non-diagonal elements are 0. And again you can see the matrix B, all diagonal elements are 1, 1, 1, and rest non-diagonal elements are 0. Again matrix C, all diagonal elements are 2, 2, 2, 2, but non-diagonal elements are 0. I think it is clear to how can we define the diagonal matrix. A square matrix is said to be diagonal matrix if aij is not equal to 0 when the value of I is equal to j, and when the value of I is not equal to j, aij is 0. Clear? And now next, after diagonal matrix, I am going to discuss the very important matrix, identity matrix. It is also known as unit matrix, and it is also denoted by a special letter I. So it is a square matrix. One more important condition is that the matrix should be square. That means a rectangular matrix never be unit matrix. And diagonal matrix, that means always identity matrix is square matrix and diagonal matrix. If the value of aij is 1, that means when the value of I is equal to j, that means a11, a22, a33 all should be 1. And when the value of I is not equal to j, that means non-diagonal elements are 0. It is denoted by in, where n is the order of matrix. N is the order of matrix. Because it is always a square matrix, that means number of rows are always equal to number of columns. That's why I have written here in. I3. I3, that means a unit matrix of 3 by 3 order. The number of rows are 3, the number of columns are 3. You can see all diagonal elements are 1, 1, 1, and non-diagonal elements are 0. And you can see also I2. I2 is a matrix of 2 by 2 order. It is unit matrix. And diagonal elements are only 1, 1, and non-diagonal elements are 0. And very important point, every unit matrix is diagonal matrix. Every unit matrix is diagonal matrix, but converse is not true always. That means very important thing, every diagonal matrix is not unit matrix, but every unit matrix is diagonal matrix. Now after getting the definition of identity matrix, it is very easy to understand a scalar matrix. There is a small change in identity matrix and a scalar matrix. Two conditions are same. It should be square, it should be diagonal, and if aij is equal to k, where k is non-zero scalar quantity, when I is equal to j, that means a11, a22, a33, they may be 2, they may be 3, they may be 4, they may be 5, because these are non-zero scalar quantity. But when the value of I is not equal to j, aij is always equal to 0. That means all non-diagonal elements are 0. Clear? Where k is a scalar quantity, it should be non-zero. I have not written here, but it is very clear the k is non-zero scalar quantity. You can see example of matrix A, all diagonal elements are 2, 2, 2, and non-diagonal elements are 0. Clear? So now important thing, every scalar matrix is diagonal matrix, but converse is not true always. That means every scalar matrix is a square matrix as well as diagonal matrix, but every diagonal matrix is not a scalar matrix. Reason, in diagonal matrix diagonal elements may be different, but in scalar matrix it is very important condition is that diagonal elements should be same. I have given example. You can see matrix A, all diagonal elements are same, they are 2, 2, 2. Now next line, every unit matrix is a scalar matrix. Every unit matrix is scalar matrix. Reason behind this, all diagonal elements are 1, 1, 1. They are equal. That's why we can say every unit matrix is scalar matrix. But every scalar matrix is not unit matrix. You can see I have written example. The diagonal elements are 2, 2, 2. It is a scalar matrix, but it is not unit matrix, because if it is unit matrix, then the diagonal elements should be 1. Now next, comparable matrices. Comparable matrices, I think you know the word comparison. We should compare two equal people. That means we can't compare the intelligence of a student who is in class 5 with a student of class 12, because the IQ level of both the students are different. Similarly, when we are going to compare two matrices, then order should be, both the matrices should be same. So I have written example, and I will discuss. First of all, what is the definition? Two matrices are comparable if their orders are same, and corresponding elements of comparable matrices are also same. That means if we take two matrices of different order, then we can't say they are comparable. And comparison between two matrices is possible if and only if both should be of same order. Sometime you will find a question on this topic for 1 marks. So example is given. I have taken two matrices of 2 by 2 order. The element of first matrix are x plus y, 5, x, 6, and the elements of second matrix are 9, 5, 6, 2. And by the definition, you know, the in this question you have to find the value of x and y. So by the definition of comparable matrices, you know, the corresponding elements are same, so we will equate x plus y to 9 and x is equal to 2. When the value of x is 2, we will put the value of x in the equation number 1. You will get the value of y, which is 7. Now upper triangular matrix. So upper triangular matrix and lower triangular matrix, these are two matrices. So now I'm going to discuss upper triangular matrix. So upper triangular matrix is always a square matrix. That means upper triangular matrix always a square matrix. If a matrix is rectangular, it never be upper triangular. So a square matrix is upper triangular matrix if the value of Aij is 0 for all elements where the value of j is more than, where the value of I is more than j. So very clear, very important thing. You should always remember it. Aij is equal to 0 for all those value of I which is more than j. So I have written a matrix of 3 by 3 order because it should be square. That's why I have taken a matrix of 3 by 3 order. You can see A11, A12, A13, A21, A22, A23, A31, A32, A33. By the definition, all the elements are 0 where the value of I is more than j. So you can see element A21 in A21 and A31 and A32. The value of I is more than j. That's why these three elements A21, A31 and A32 all are 0. And rest elements are non-zero. You can see that's a very example, very important example. That means 0 make a triangle. 0 make a triangle below the principal diagonal. 2, 1, 7 are the diagonal element. 2, 1, 7 are the diagonal element, and this line is called principal diagonal. So you can see in this example all 0 are below the principal diagonal. Clear? And now lower triangular matrix. So lower triangular matrix also should be square. It's just opposite of upper triangular matrix. A square matrix is said to be lower triangular matrix if the value of Aij is equal to 0 for all the value of I is less than j. For all the value of I is less than j. So you can see a matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32 and A33. So all the elements where the value of I is less than j are 0. So you can see A12, A13, A23. In these three elements you can see the value of I, which is less than j or not? Yes? Yes. 1, 2, 1 is less than 2, 1, 3, 1 is less than 3, 2, 3, 2 is less than 3. That's why these three elements are 0. I have written example 2, 0, 0, 4, 1, 0 and 5, 1, 6. Clear? I think it is very clear to you people. So types of definitions of matrices is now finished, and after this video I will upload one more video of operation of matrices, and after that I will upload a video of transpose matrix and what are the properties of transpose matrix. After discussing these two topics, I will discuss some more types of matrices which are symmetric, skew symmetrics, and some more matrices. Okay, so I think you are watching my YouTube videos, and I will upload it regularly. And if you watch it before my online class, then I think the topic will be clear to you. Okay, thank you. Sorry, thank you very much.